Hello guys, welcome back to Manala's Arc. I hope you've all been well, you've been enjoying maths and studying maths, right? So firstly, I want to extend my apologies. My voice for this video might not be good enough. Like working at school, stretching my voice every day, talking to people got me to this position. I hope when we go to school holidays or probably during the weekend now, my voice will recover and I'll have content with a better voice for you guys. So now with this video here, I want to talk about probability. This is grade 10 probability. I already had a video from 2023 talking about this concept of probability. However, the other day I was watching that video and I feel like that video leaves a lot on the table to be desired, right? So I feel like I have too many opinions about that video. I love that video. I loved it when I put it there at the time in 2023. However, I feel like I can make a better video to that compared to that one. So here is the version, the second version now of probability. So this video here is going to talk about these items that you see here. I have the probability of an event, reduced sample space, relative frequency, up until this part here. So this video, it's actually going to be long. And I hope when you finish this video, you're going to end up understanding probability very well. So please make sure that you have a pen and paper with you here because you really have to work. But the aim is that at the end of this video, you should be able to understand probability to the T. Right, so now let's start with probability of an event. Now, what is probability? What do we refer to when we talk about probability? Right, so in this situation, when we do talk about probability, we are talking about the chances of something happening. For instance, let's say you are tossing a coin, right? Tossing a coin. It's been a while since I used this writing pad. It feels weird now. So when you're tossing a coin, there are two outcomes that are possible. Either you're going to get heads or you're going to get tails. So we have things that we say are theoretical, right? According to theory, when you toss a coin, either you're going to get heads or you get tails, right? And then what are the odds of you getting heads? Usually the odds of you getting a heads when you toss a coin is 50%. So we are saying that you have a 50% chance of getting heads, you have 50% chance of getting tails. Those are the odds, the probability when you're tossing a coin, right? And then now this probability, now what you have to understand is that probability can be represented in three ways. It can be represented as percentages. Probability can be represented as fractions. And probability can be represented with decimals. Now, in that situation, what do we have? Whenever we are working with percentages, we know that percentages should add up to 100%. Probabilities here, they should add up to 100%. And then whenever you're working with fractions or decimals, they should add up to 1. That way. So the fractions you have, they must add up to 1. The decimals you have, they must also add up to 1. That's probability for you. And then we have several items also. Let me remove this. In probability, we have terminologies, and those terminologies, they go as follows. Right. Let me put that for you here. We have a term that is referred to as the experiment. We have a term called outcomes. We have a term that goes by sample space. We have a term that talks about an event. So these words here, you are going to see me throw these words a lot. I'm going to refer to things using these words. Oh, and also let me not forget this one. There's a term that is referred to as set notation. Right? Then these terminologies, I'm not going to explain them now. There is no point to it. I'm going to explain these terms when you see me use them in a situation, right? So that's what we have there. So now, and then we have something that we call the probability of an event. Let me show you what I mean by that. There's an equation that says the probability of an event. Let me say probability of an event. You write it this way: probability of an event. That's the E inside the brackets there. We are saying this is equals to the number of possible outcomes for that event all over the number of all items in the sample space. The S here represents the sample space. Now, you might not get that now, but as soon as we start using these things, you'll start understanding them, right? But let me throw something. Let me throw something for you. Let's say you are rolling a die. A 6-sided die. You know which die is this one, right? A 6-sided die. So now in this situation, when I'm asking you for the sample space, the sample space, it's everything that is possible in this 6-sided die. So we have something that we call a set notation. When I'm asking you to give me the set notation, you're going to put for me an S is equals to, then you use this fancy brackets, going to say 1, 2, 3, 4, 5, 6, and then you close that fancy bracket again like that, this way. This is called the set notation. Let me use a nice pen here. This is the set notation. You see how I wrote those things? That is what it is. This part here, every time I ask you to write for me something in set notation, you write the symbol, the equal sign, those fancy bracket, and everything that is possible in that set notation. So now I was talking to you about the sample space. Now with regards to the sample space, we are saying the sample space, it's everything that is possible in this die. So which means anything that can ever happen in this die, it will only come from these values that I see here, right? So I'm saying when you are rolling a 6-sided die, you have an event. This question continues. An event A, whereby event A is chances of getting an even number. There we go, right? So now when I say give me the probability of that, when I say what is the probability of event E? No, it's event A. Let me write it properly. I made a small mistake. What is the probability of event A? So the answer that you're going to give me, I want to break this thing down for you first. When you have to answer me here, you have to consider the statements that we have. We are rolling a 6-sided die, right? The 6-sided die has this as the sample space. These are all the possible options, and then it's written there in set notation. Now to answer this question here, question number 1, it says what is the probability of us getting event A, right? Now for you to do this, first you need to give me this as a formula. You're going to say the probability of event A. You see how I write it? Yeah, the probability of event A is equals to the number of items in event A all over the number of items in the sample space. You see what I did there? That's how it needs to be. It always needs to start with this part. You give me the formula, and then from there, that's when you substitute. How many possible options are in event A? Now, event A, it says these are chances of you getting an even number. Now, you go to the sample space. You look at all the even numbers that are there. How many even numbers do we have? We have 3 even numbers. So I put 3 there. These are the odds of us getting an even number. And then this bottom part, the denominator says the number of items in the sample space. We go to the sample space. This is the whole sample space. How many values are in the sample space? We have 6 values. Now, probability should always end up with a simplified fraction. We good? So now, we are saying here the probability of us getting event A is equals to, what is the simplified version of 3 over 6? That is 1 over 2. This way. This is how you would answer a question like that for me. Now, let's move on to the next part. Here's a question we can quickly do. It says a 6-sided die with faces marked 1 up until 6 is rolled, right? It's like an extension to that question that we had there. Oh, let me choose a proper color here. Choose proper thickness, right? So we are saying a 6-sided die with faces marked 1 to 6 is rolled. Question A. Write down the sample space in a set form. Let's do that. Let me choose a darker shade here. This is nothing. So to answer A, they want the sample space in a set form. The symbol for sample space, it's S. Then we put this thing here. What is the sample space of a 6-sided die? It's 1, 2, 3, 4, 5, 6. There. If it's 2 marks, you get your easy 2 marks there. Easy as that. Right. Question B, it says if A is the event in which the die lands on an even number, B is the event in which the die lands on a number greater than 4. Number 1. So B, number 1. Write down the events A and B in a set form. So event A. Set form, remember, this is how you always do it. What is happening in event A? We said event A is us getting a die landing on an even number, right? So which ones are the even numbers? From the sample space, it's 2, it's 4, it's 6, right? So I have 2, I have 4, I have 6. There we go. And then number 2, calculate the probabilities of, oh, I'm missing something. Event B, right? Event B is, they said event B is the situation whereby the die lands on a number greater than 4. Which number is greater than 4? It's 5, it's 6. So I'm going to write here 5 and 6 from the sample space. Everything comes from the sample space, guys. Be good. So number 2, it says now calculate the probabilities of event A and B. Let's start with A. The probability of event A is equals to, you always start with the formula first. The number of items that are in event A all over the number of items in the sample space. You always do it this way. Always. And be careful. You see how I did my notation? I also expect you to do something like that. Now you're going to say the probability of A is equals to how many items are in A. A has 1, 2, 3 items. So it's 3 all over. What's in the sample space? Sample space has 6 values. Here they are, 6 values. So I write 6 here. Now, this probability as a simplified version. Remember, probability must always end with a simplified version. What is 3 over 2 in simplified form? That is 1 over 2. There. Done with event A. Now, event B. Also, you start with the formula here. The probability of event B is equals to the number of items in event B all over the number of items in the sample space. This way, right? Now, the probability of B is equals to how many values are in B? We have 1, 2. So that is 2 over how many values in the sample space? Here we have it. The sample space has 6 items. Now the probability now has to end in the simplest form as always. What is that? That is 2 over 6 when it's simplified. You can just put this thing on a calculator sometimes to stop yourself from suffering, right? But then when you put this on a calculator, you'll get 1 over 3. Is that proper? Perfect. Now let's go to the next example. Here's the next question. This question says, a coin is tossed twice. tossed twice, each coin lands on either heads or tails, right? The following events are defined. Now, this is a tricky one. You have X, whereby the coin lands on heads twice. You have event Y, where the coin lands on tails exactly once. And then you have what is this? Event Z, whereby the coin lands on heads at least once. Now let me do the situation for you. Let's say you have a coin, right? Here's a coin. This coin, you toss it. There are two options. Either it will land on heads or tails, right? And then after it lands on heads, you toss it again. It will also have a chance of landing on heads again, or this time on tails. We good? So the first time you tossed it, if it landed on tails and then you toss it again, it will also have two options of getting heads or tails. So now in this situation, this branch here, it represents what? That you'll toss a coin, it will land on heads the first time and the second time. So this is heads and heads. And then this branch represents the fact that you can toss this coin, it will land on heads the first time and then land on tails the second time, right? And then this branch here, it represents the fact that you can toss a coin the first time such that it lands on tails, and the second time it lands on heads. And then this branch represents the fact that you can toss the coin the first time it will land on tails, and the second time it will land on tails again. So now these are the outcomes we have, right? Let me write them here. We have heads and heads. We have heads then tails. We have tails then heads, and then we have tails and tails. So we have 1, 2, 3, 4 outcomes when we toss the coin twice. Now let me remove the other area here. I have all that I need. So now that I have the outcomes like this, then now I can go to my sample space like the question here wants me to. So question A, let's answer that. My sample space, it's going to have what? I put those fancy brackets. I have the first outcome, which can be heads and heads. I have another outcome, which can be heads and tails. I have another outcome, which can be tails and heads. I have another outcome, which can be tails and tails. This way, right? Done with the first question. If it's 2 marks, I have my 2 marks there. Question B, it says, calculate the probability of X as number 1. Right. So let me make sure. Boom, boom, boom. Okay. Yeah. Probability of X. What is X? X, it's us having heads twice. So that is going to be the probability of X is equals to the number of items that are in X all over the number of items in the sample space. Now, in this situation, our substitution is going to be in X, it's 1. I have the situation whereby my event will land on heads twice. How many times does that occur? It only occurs here that my thing will land on heads twice. So I have one of those things. Out of how many? Out of the whole sample space, which has 4 outcomes. See that? That's X there. Done. Number 2. Number 2 is looking for the probability of Y. Now, what is the probability of Y? The probability of Y, it's number of items that are in Y all over the number of items in the sample space. What does Y want? In this situation, Y wants tails exactly once, right? That the coin will land on tails exactly once. Now, that happens here. We have 1 tail here, and here we have 1 tail here. So I have, let me write this. I have 2 possibilities that the coin will land on tails once out of the whole sample space. The sample space has how much? 4 outcomes. Now, simplified, that gives me what? 2 over 4 is the same as 1 over 2. Now, the next part is looking for the probability of Z. The probability of Z, it's number of items that are in Z all over the number of items in the sample space. So you make your substitution. That is how many items are in Z. Z is said to be that the coin will land on heads at least once. So let me use a different color here. The situation whereby the coin will land on heads once, it's here we have at least one head. Here we also have at least one head. And then here we have two heads, which also counts for at least one head. So we have three situations where we get at least one head there. Now the substitution here is going to be, I have 3 outcomes out of 4, because of 4 is the sample space whereby the coin will land on at least one head. That is that. Let's go to the next example. So here we have a situation of reduced sample spaces. Now, when we talk about reduced sample spaces, they mean different things, right? So you have your normal sample space that we have in the past examples that we have. In a situation of us rolling a die, we had these 5 options as our sample space. I mean, these 6 events as the sample space. Now, what happens here is that if ever I'm to give you an extra information, any extra information that makes this data here to be reduced, the new sample space that you're going to have, it's called the reduced sample space. So if I'm telling you that from here you're only working with odd numbers, your odd numbers now will create your new sample space. So let's look at this example here to save time. I've created this example for you, and through this example you will know what the reduced sample space means. So far you already know what's a sample space, so this example will just help you understand what is a reduced sample space. So let's go through the question. It says the names of 7 people are placed in a hat and 1 name is drawn at random from the hat. It says the name and sexes of 7 people are as follows. So you have the name and the sex here, and these are all the names. And it says question 1, it says determine the probability that the name drawn belongs to a male person. So this part here shows you whether the person is a male or a female, and we just want the probability whether a person is a male or a female just from this data alone, right? So for you to give me that, you're going to say, let me find my mouse right here. You're going to say now the probability of getting a male. Remember, notation is everything. If you notate your question properly, then that gives you a mark. So this is the number of people who are male over the number of items that are in the sample space. Remember, you always need the formula for that, right? So for that to happen, we have a male here, we have a male here, we have a male here. So we have 3 males. That's what's possible. That's the number of males. And then the whole sample space, we said that we have 7 people. So we have 3 over 7. That is already in the simplest form. So we don't need to simplify this further. Now, going to question B. Let's go through question B. It says, suppose it is known that the name drawn starts with the letter L. Now, this information, it reduces your sample space. This new information, it's telling you that from the sample space that you have, you must reduce that sample space and now work with the new information that you have. So now we are working with what? With the names that have L's. So here's the first name here. Here's the second name here. And I don't know why this thing highlighted it. I think it's the spelling thing. Let me remove that. Let me choose that. Ignore all. Ignore this. This thing doesn't detect African names, but that's fine. That's how these things are. Yeah, I shown you that this is the name that starts with L, another one, and another one here. So that's my new sample space. That is the reduced sample space now. So to get to that, we have question 1, which says write down the new sample space. That's what they want. So I'm going to say my new sample space or my reduced sample space, because it is the reduced sample space. The notation is no longer going to be normally as we always see it. It's going to have a subscript of R below here. So, and then you put your equal sign, then those fancy brackets, then you give me the outcomes there. The first name there, the second name there. Let me write this properly. and the last name there. Hope you can see my handwriting. So this is my reduced sample space now. And then I have to answer the question based on the reduced sample space that I have. So question 2, it says, taking this new information into account, what is the probability that the name drawn belongs to a male person? So I go to my names there of the reduced sample space. I see this person is a male and this person is a male. It's only this person who's not a male, right? From my reduced sample space. So I need to start with an equation. I'm going to say the probability of a male, again this time, is equals to the number of males that I have over the number of items that are in the reduced sample space. Remember the subscript R there. So now, how many males do I have in this situation? I have 2 males over how many people are in the reduced sample space? I have 3 people. So this is 2 over 3. So that's what I have, right? So it's as easy as that. Now let's go to what we call relative frequency. So for relative frequency, we have a question like this one. It says a coin is tossed 100,000 times. The coin lands on heads 49,716 times. Calculate the relative frequency of the event. The event, it's the coin landing on heads. And then establish whether it approximates the theoretical probability. Now, when we started this lesson here, we started by throwing words like experiment, outcomes, set notation, and things like that. And now the word that we've used so far, it's events, it's outcomes, it's set notation, it is those are the words we've used so far, and reduce the sample space. Now the word that comes into play here, it's the word experiment. So there's here a coin being tossed 100,000 times. That's the experiment, right? And then the coin landing on heads, that's the event, right? I mean, the coin having options to land on heads or tails, those are the events. And then the outcomes, it's this landing on that exactly. And then we have n here, which is the amount of times this coin lands on that after we experimented this thing 100,000 times. So let's look at this one here. We are saying now here, the first thing we have to be mindful of is a formula. We have a formula that says the relative frequency is equals to the frequency over n. Now, what is n? N is supposed to be the number of times this experiment was done. So this experiment here was done 100,000 times, and then the frequency is how many times this thing here landed on the items that on the outcome that was needed in this situation. So let's do this. I'm going to divide this section into 2 parts, and then we have to understand that we are going to work with the relative frequency and we are going to work with theoretical probability. Hope you can see that right there. A question like this, most of the times, as in like almost all the times, you're going to get one of these questions, not more than one usually. It's just one question in a question paper. It doesn't carry a lot of marks. Expect at least to gain 4 marks from this question. Now, I want us to start with theoretical probability. According to theory says whenever you're tossing a coin, where's the pen? Here. Whenever you're tossing a coin, you have 2 outcomes. And then those 2 outcomes, let me write it here. The coin, those 2 outcomes, it's heads and it's tails, right? Now let's put it this way. In those 2 outcomes, the chances of you getting heads, it's what? It's 50%. That's theory. And the chances of you getting tails, it's what? It's also 50%. That's theory, right? There's not much to argue there. This is just how it is, right? So if I have to rewrite this thing in the way that I've been using proper notations, I'm going to say the probability of heads is going to be, let me write it in all the ways. We said probability can be a fraction, it can be a decimal, and it can be a percentage, right? They all represent the same thing. I have a half here, I have 0.5, I have 50%. They all represent the same thing. And then now, relative frequency, now we have this thing that we refer to as relative frequency, and you'll see now what it means. The formula first starts by saying relative frequency is equals to, here it is here, is equals to frequency over n, right? Let's make substitutions. What is f? Frequency, it's the amount of times you got the outcome you are testing, right? So here's this outcome here. Here is heads. This thing landed on heads 49,716 times. So I have 49,716 here. And then I have n. What does the n represent in the formula? It represents the amount of time this experiment was tried. So this experiment was tried how many times? 100,000 times. A coin was tossed 100,000 times for us to get this outcome 49,000 times, right? So I'm going to put 100,000 here. And then I just get the relative frequency. To be honest, there's no trick here. You just use your calculator. So as you can see there, the solutions from my calculator, I got 0.47716, right? Let me write that down. I said I have, where's my pen? I can't see the pen. I said 0.4776, right? And then I want to see this thing now as a percentage, right? Let me see, let me check something here. I rechecked my answer there, and then on this party I saw that I wrote in a 7 instead of a 9, and then so this thing, when it solves out, it becomes not 0.47, it's 0.49716. 0.49716. So let's fix that. I have 0.49716 this way. So now this thing here, I want to convert this to a percentage. If I convert this to a percentage, my relative frequency is equals to 49.72%. Now, you tell me, this thing is asking whether this value that we have from relative frequency, now this is the relative frequency, is the relative frequency from the actual experiments that were done 100,000 times, yielding heads, because of, like, in real life, when you toss a coin 100,000 times, this theory of saying the odds are that it will land on heads 50% of the times, it's not really true all the time. So in this situation, it landed on heads 49,716 times. So deviating from the theory that says it lands on the 50% of the times. However, our relative frequency gave us 49.72%. Now, does this approximate the theoretical probability? Yes, because it's really not far off from the theory of 50%. So which means, to answer their question, our answer here will be yes, because when we round this off to the nearest whole number, it will still give us 50%. Easy as that, right? So for relative frequency in probability, you have to know that you have your theoretical probability and you have the actual event that takes place. And when the actual event occurs, it gives you outcomes, And with those outcomes, you have frequency because the experiment is done multiple times. So you divide your frequency by the amount of times the experiment was performed, you get your percentage. Then you compare your percentage to the theoretical probability to see if your percentage that you got from the relative frequency, does it match the theoretical probability? Now, if your relative frequency doesn't match the theoretical probability, what it means there is that this experiment does not match the theoretical probability, which means the two do not go hand in hand. One of them is not proper. It'll be good. So that is how the questions will come. So that is all with the relative frequency things. I don't want us to do much of those. We have more difficult things coming into our side. Now let's move to the concept of Venn diagrams. So here's a situation of Venn diagrams. Now this one is going to take a toll on this video, but I'm going to try to explain this as best as I can. So I have this example that I've used in the beginning of this video, right, with the very second slide to this video. So it says a six-sided die with faces marked 1 up until 6 is rolled. A is the event in which the die lands on an even number. B is the event in which the die lands on a number greater than 4. And then the question here, it's supposed to be draw a Venn diagram. Let me just type it out. Oops, I'm messing things up now. So yeah, the question here should be draw a Venn diagram to represent the outcomes in the above scenario. There we go. So this thing usually it will be how much? It will be 4 marks. It has been like that for grade 10. So that is that. Let's go through it. Now in this case, whenever you have a Venn diagram, you are supposed to represent your Venn diagrams in circles and then in rectangles, right? So what I need you to do first is to verify whether your two events have what we call an intersection. Now that's another way to it. So let's do this step by step. Let's start with the sample space. The sample space, it's everything that is possible in this experiment, right? Now we are saying the sample space has 1, 2, 3, 4, 5, and 6 this way. This is all that is possible. So which means in my Venn diagram, all the values that I'm going to see are these ones. They should all appear in the Venn diagram. And then we have event A. We need to show that event A has what? They said here that event A is the die landing on an even number, right? So that is 2, 4, and 6, right? And then we have event B. What is event B? Event B is us getting a number greater than 4. That number is 5 and 6. You see that? And then now what happens is that you are going to represent every event. Let's say this is event A, you're going to represent it with a circle. You write A outside the circle, and everything that's inside event A, you write it inside the circle. 2, 4, and 6 this way, right? And then you have event B, you write B outside the circle. Everything that's inside event B, you write it inside the circle, right? However, it's not as easy as that. You have to consider the fact that these events, they might intersect at some point. Remember, keyword intersection. So we start with what we call a sample space. You have a rectangle like this way, and then you write the word S to tell us that this is the sample space, right? And then you have event A. There is event A. You write the A outside. Afterwards, you have to be considerate of the fact that these two events that are happening, they might share outcomes. So I do see a 6 in event A, I do see a 6 in event B. So which means the 6 here, we cannot write two sixes in this Venn diagram because we only have one 6 in the sample space. So what does that mean? It means now that these two events, they must share an outcome because we can only have one 6 in a die. So I put this circle that overlaps to the circle of event A. So this is event B, right? And then you start with the intersection, something that these two events share. So because this event has 6 and this event has 6, we're going to write 6 here at the intersection. That's what we call the intersection, the point where event A and event B meet, right? And then afterwards, you go to items that are only in event A. You write them in the part that is only about A. So you write 2 here, you write 4 here. And then you go to event B, you write all the outcomes that have to do with only B. So you write 5 here because it only belongs to B. And then you be like, okay, you go back to your sample space. The sample space didn't just have 2, 4, 5, and 6. There are values that are missing here that are not in event A and they are not in event B. What are those values? Those values that you have, it's the value 1 and it's the value 3. So from the two events, 1 and 3 were not represented. From A, it was not represented. From B, it was also not represented. Therefore, 1 and 3, they stay inside the sample space, but they don't go to A or B because they have nothing to do with those events. Now, what you see here is a Venn diagram, and this Venn diagram, we call it an outcome Venn diagram. Now, we have 3 types of Venn diagram, and this is just an outcome Venn diagram. How would you know that they want you to give them an outcome diagram? There will be keywords in the question that request you to do that. So in this situation, our keyword was that give us a Venn diagram that represents the outcomes in the above scenario. Now, what other Venn diagrams are there? Other Venn diagrams that we have is the following. So suppose that instead of them asking you that you should give us an outcome Venn diagram, now they ask you to give us a Venn diagram that is number of outcomes. Now, that's another type of a Venn diagram. The first one is an outcome Venn diagram, and then the second one is the number of outcome Venn diagram. So I still have these things here. I still have the sample space in set notation. I have event A in set notation, and I have event B in set notation. So my Venn diagram, just like the previous one, I'll have the first circle representing event A. I'll have the second circle overlapping because we already know that these circles are overlapping, representing event B. And all these things, they'll be inside the sample space rectangle, right? So here's the rectangle representing the sample space. So I put the sample space symbol here, right? Now, in terms of number of outcomes, here you don't write for me the actual outcomes. Instead, you use the number of outcomes. So remember, we start with the intersection. I know that 6 is being shared between the two events. However, I do not write a 6 here. I write the number of events that are being shared. So I have one event being shared there. We good? And then in event A, number of values that are exclusive to just A, I have 2, I have 4. So I have how many events? I have 2 outcomes, that are exclusive to event A. We good? And then I go to event B. Event B, how many outcomes are exclusive to B? I have 1 outcome, which is 5. I have 1 outcome that is exclusive to B. And then to the rest of the sample space, remember we had 1 which we said was not represented in event A or B. We have 2 that was not represented in event, 2 is represented. 3 is the one that is not represented in A or B. So I have 2 values that are not represented in the 2 things. So I have 2 values not being represented. So in total, in the sample space, I have how many values? 6. I have 1 in B exclusively. I have 1 in the intersection. The intersection is the point where the 2 events overlap. I have 2 in event A alone, and I have 2 in the rest of the sample space. So that's another Venn diagram there. Let's go to the next one. So the next Venn diagram, we call it the probability Venn diagram. Now remember this. The first Venn diagram was an outcome Venn diagram. The second Venn diagram was the number of outcome Venn diagram. Now the third one and the last one, it's the probability Venn diagram. Now, for us to get to the probability Venn diagram, I need us first to start with the outcome Venn diagram, right? So let's do that quickly. So here we have event A, we have event B. So here is A and B. These things are in a sample space. And we wrote the sample space here, right? So events that are in both of them, it's 6. That's the outcome that's in both events, right? And then what's exclusive to A, we have 2 and 4. And then in event B, what is exclusive is what? It's 5. And what's not in event A or B is the value 1 and the value 3, right? Let me put the 5 properly there, right? So this is an outcome Venn diagram. Now, for you to give me a probability Venn diagram, you are still going to give me this right there, and you give me this overlapping there. I have event A, I have event B, and all these things are in a sample space this way here. So my sample space in probability, my probability is supposed to add up to 1. That's if I'm working with decimals or I'm working with fractions. Remember that. And if I'm working with percentages, my probability should add up to 100%. Now here, what will the probability look like? Probability, remember, it's the number of your event over the number of items that are in the sample space. That's how it is, right? So I want to start with this area here. According to this Venn diagram, we have 2 events. So I have 2 events out of the outcome, which is 6. The sample space has 6 aspects. So now in this case, let me write it here so I can simplify it. This part here in its simplified version, it's the same as 1/3. We agree on that one. So here I'm going to write 1/3 instead of 2/6. Your probability should always end up as with the simplified fraction. So I have 1/3 here. You understand what is why it is 1/3, right? And then now to the next part. The next part, I want to find out the probability of the intersection. This part where the 2 circles overlap. How many values do I have there? I have 1 value. Out of how many values in the sample space? 6. Like that. So this is already the simplified version. So I don't need to simplify this further, right? And then I go to B. B, I have how many items in B alone? I have 1. Out of how many items in the sample space? 6. This way, right? And then I go to outside event A and B. How many items do I have here? I have a 3, I have a 1 there. So I have 2 items. That is 2 out of the sample space has 6. And I have to simplify that. Also, again, this is 1/3. So here I get 1/3 outside the sample space. So this is the last probability. You can write this to me in terms of, remember that, you can write this to me in terms of fractions, right? You can write this to me in terms of decimals, and you can write this to me in terms of percentages. That is highly up to you, which option you feel like it's better for you. I always prefer fractions. We usually use fractions and decimals, right? It's easier to work with those things than with percentages. I hope you all good with that. Now let's do a quick recap with the type of Venn diagrams we have. So we said here that we have 3 types of Venn diagrams. In those 3 Venn diagrams, what we know that we have, number 1, it is the outcome Venn diagram. This is one way, outcome Venn diagram. We also have the number of outcome, Venn diagram. And then we have lastly the probability Venn diagram. Probability. Hope that makes sense. So every question will either want this Venn diagram from you, or this one, or this one. Always make sure that when you have a question, you look at the keywords. What do they want? Do they want an outcome Venn diagram, a number of outcome Venn diagram, or a probability Venn diagram? Right, we said. So afterwards, we have questions around Venn diagrams. We can ask you to draw a Venn diagram and then you answer some questions, or we can give you a Venn diagram and then you answer some questions with that. Now, with this situation, let's move on to some questions and see how can we answer questions pertaining Venn diagrams. Here's an easy question. Please try to see if you can pause the video and answer the question on your own, and then unpause the video and see if you get the same solutions as me. Right. Now let's get to it. Number 1. Let's read the question. The letters of the word randomly are written on cards and placed in a hat. One card is drawn randomly. Let A be the event in which a vowel is drawn. Now that is easy. A represents a vowel, right? I hope we're getting this right. So from the word randomly, vowels, we have A and we have the word O, right? So let me do a Venn diagram of that. I'm going to have the sample space here. So S for sample space, you can put S some anywhere. I'm putting it here so that you can see that you can put S anywhere. So randomly has 2 vowels. Here's my circle representing the event A. So I have A and O inside there. And then what is not inside the event? What is not the event? It's the alphabet R, it's the alphabet N, it's the alphabet D, it's the alphabet M, is the alphabet L, is the alphabet Y. So everything else, it's not inside the event of A, which has the vowels A and O, right? That's number 1, easy as that. And then it says write the outcomes of the sample space and events in the set form. So that's number 2. So for the outcome of the event, I have A and O as I've written it above there, and then the outcome of the set notation of the sample space, I have the word randomly. There we go, separated by semicolons, very important, right? So that is the answer there. Now to the next question number 3. It says write down NA. Now what is NA? NA, it's the amount of values that are in the event A. The amount of values in the event A, I have 2 items inside event A. Easy as that. Number 4, it says write down the probability of A. Now the formula first, remember the probability of A, it's number of items inside event A over number of items in the sample space. Now that makes probability of A to be equals to how many things are in A? I have 2. How many things are in the sample space? Well, I have 1, 2, 3, 4, 5, 6, 7, 8. 8 things in the sample space, right? Now in a simplified version, this is the same as 1 over 4. Easy as that. I hope you got this correct. Let me choose another question, something a little bit interesting this time for you to stretch your mind, right? So let me see that. Now look at this question here. I need you guys to pause this video and see if you can attempt this question on your own first before you proceed to see the solutions. All right, this is very interesting. Now here, number one, let's read the question. It says, consider the Venn diagram here on the side. This is the sample space. It shows you everything that's in the Venn diagram. It says, write down the sets S, A, B, and C. All right, so we write those things in a set form. So let's start with S. What does S represent? The sample space. So I see that I have A, B, C, D, E, F, G, H, I, J, K, L, M, N, up until M, right? So that is in small letters: A, B, C, D, E, F, G, H, I, J, K, L, M, N. That is the sample space. And then for event A, I have A, B, C, D, E. So I put it there: A, B, C, D, E, right? And then for event B, what do I have in event B? D, E, F, G, H, I. D, E, F, G, H, I. Right? And event C, for event C, I have what? J and K. See how beautiful is that? Now number two. Number two, it says, write down the number of items that are in A, B, and C. So the number of items in A, I have 1, 2, 3, 4, 5 things. So I have 5 things in A, right? The number of items in B, that is equals to what? 1, 2, 3, 4, 5, 6. I have 6 things in B, right? And then in C, I have 2 items in C, as we can see there, right? Number 3, it says calculate the probability of A. Probability of A, we know it's number of items in A over the number of items in the sample space, which gives me what? 5 over what's in there? It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So it's 15 over 14, right? Probability of B, let me cut this here. Probability of B is equals to number of items in B over number of items in the sample space. How many things do I have in B? I have 6 there. Oops. I have 6 items in B, as you can see here. So I have 6 out of what's in the sample space, 14, right? This needs to be simplified. What is 6 over 14? This is the same as 3 over 7. Cut it there. And then probability of me getting a C, it's how much? It's the number of items in C all over the number of items in the sample space. That is the same as us having 2 over 14. What is 2 over 14? That is 1 over 7. Beautiful. See then, that was number 3. Now number 4 now. Number 4, it wants us to redraw the Venn diagram showing the number of outcomes, right? Now let's do that. Let me create some space here. So for number 4, it says redraw the Venn diagram showing number of outcomes, right? So this is us now drawing the Venn diagrams. So the Venn diagram that they want, it's the one that shows number of outcomes. Remember what I said? From the question, you'll see keywords that tells you what Venn diagram do they want. So this Venn diagram so far, it looks like this and like this. Of course, you can copy it to the T. We're trying, guys. So here's the sample space. Remember, you can write the S anywhere. This is event A, this is event B, this is event C. How many things are in event C? We have 2. How many things are in B alone? Well, we have 1, 2, 3, 4. I put a 4 here. How many things are in the intersection? I have 2 things. How many things are in A alone? I have 3 things. How many things are in the rest of the sample space? It's 1, 2, 3. So I put a 3 here. So this thing has how many things? It has 4, 6, 8. 8 plus 6, that's 14. There we go. Another question, it says redraw the Venn diagram showing the probabilities. Now that's number 5. So this will be the last question for us. I have this part and this part here. I'm redrawing the Venn diagram, right? Showing now the probabilities. And I have this part here. So I have A, I have B, I have C. Now let's start with the C. The C has how many things? It has 2 out of 14 items. That's simplified. It's 1/7. So I put 1/7 here. And then I have B. B is what? I have 4 items there. So it's 4/14, which is the same as 2/7. So here I have 2/7, right? There we go. And then I go to this part now, the intersection. The intersection, it's 2/14. We said 2/14 is the same as 1/7. So this is also 1/7. And then I have A. A has how many things? It has 3 things. So that is 3/14, and that cannot be simplified. And then the rest of the sample space, it also has 3/14, and that cannot be simplified. So that's the final part of it. We good? So now here's what I want from you now. I want you guys to try this question for me, right? I don't think it's too terrible. I think you'll be able to do it. In fact, it's easy like the rest, right? So please try this question on your own and see if you can get the solutions to it. And I hope all the things that we've discussed up until this point of the video, you understand them, because here we're covering the basics of probability. We haven't gotten in it, right? We are halfway through. We are still going to deep dive into the difficult things. I see that this video now has crossed an hour, and I really don't want to make a 2-hour video because I know you're not going to watch it. So this is part 1. Then I will upload part 2 that has the intricate details now of probability, the meat and bones of probability. So please make sure you understand all there is to understand about this one, so that when you move to the next video now, you don't struggle at all. So thank you for watching, guys. If you've reached this far, I'm grateful for having a person like you on my channel. Please make sure that you have subscribed to the channel and you will like the video, hopefully, and see you soon. I'll see you on the next video. Goodbye, guys. Oh, also I wanted to throw in something here. I saw a comment somewhere that said my accent on the video, it's not right? Yes, I know my accent is bad. If you want a polished English accent, I'm sorry, I can't give that to you guys. I really cannot. This is just how I speak, and at the age that I'm at now, I doubt that will change. I'm sorry if you can't hear me in that case. I know I'm not the worst version there is in accents on YouTube content, but hey guys, I'm sorry, I can't change that. And so if that bothers you, I'm really sorry about that, and I hope you'll tolerate me on the other videos or the next video that you bump into. I hope you just hear my content for the sake of the content. Okay, goodbye, guys. Don't forget to like and share. No, I know you won't. Okay, don't forget to like and subscribe to the channel. Okay, thank you, guys.